Okay, so 9.1 says multiplying and dividing rational expressions. So what the heck is a rational expression? A rational expression is a ratio of two polynomial expressions. Think about ratio. Another word for ratio is fraction. And you're going to say, not that lady. I know how y'all feel about them. I got my daughter the other day to say she loves fractions, and I was like, yes! Okay, so all we're talking about is polynomials inside of fractions. So there's polynomials in the numerator and polynomials in the denominator. And remember, a polynomial is just something that looks like that bad boy, right? Okay? It can also look like that. So those are just polynomials. So number 1 there says simplify 3y times y plus 7 divided by y plus 7 over y squared minus 9. Okay, think about fractions in general. Go back to 3rd, 4th grade math, right? When you were simplifying fractions way back in the day, like, I don't know, 4/12. How would you simplify something like 4/12? Yeah, you'd get rid of a common factor, right? When you first started it, you're like, okay, the numbers that multiply to 4 are 1 and 4. And then they multiply to 12 are 4 and 3. And then you said, oh, hey, look, they have a common factor, right? I can cancel out the 4s, so this guy becomes 1/3. We're still doing that. But now we're doing it with variables. So if you look here at number 1, what's a common factor? Y plus 7. Okay, well, if it's common, let's get rid of it. All right, well, in order to determine if we've gotten rid of everything, we should probably make sure that these guys are in their complete factored form. So what about that denominator? I mean, 3y is in its completely factored form, but what about this guy, y squared minus 9? Is he factored down all the way? Close. Yeah, he's the difference of squared, so yes. So this guy becomes 3y over y plus 3, y minus 3. Okay, not horrible, right? Does it have any more common factors? Remember, this is one whole unit. He's got to look just like that in order to be a common factor. So yeah, he doesn't have anything else. He's completely simplified, right? All right, so we simplified him. The only thing we could get rid of was the y plus 7. And then it says, under what conditions is this undefined? Well, how do we get things undefined? Or what happens? Where would there be a 0? In the denominator, right? So I don't want to end up with 0 in my denominator. Okay. So if I can't, undefined means I can't divide by 0. Whoop. That's a 0, and I can't spell this morning either. There we go. All right, so let's think about things that would make this guy equal to 0. Well, let's set it equal to 0. Let's make it equal to 0 and say, hey, you can't be that. So if y plus 3 equals 0, then y would be negative 3, right? And then we'll say, well, can't be that. And then I'll say, okay, well, y minus 3 could be 0. So I'm going to add 3, so y would be 3. Well, I don't want it to be either that. So this guy's undefined when y equals negative 3 or when y equals positive 3. When you write an equal sign, you put the slash to it. It just says, nope, you can't be that, okay? If it were equal to that, so if I plugged a negative 3 in here, I'd get negative 3 plus 3 would be 0. So I would divide by 0. Can't do that. If I plugged in a positive 3, I'd get 3 minus 3. I'd get 0, so I can't divide by 0. Does that make sense? Okay. So look at number 2. Number 2 says, for what values of p is this guy undefined? Okay, well, let's just focus on our denominator. P squared minus 2p minus 15. Is that guy factored? Yoser. Could we factor him? Yes, okay, so here we go. I have a minus and a minus. What are my signs going to be? Minus and a plus. Perfect. Thankfully, there's no coefficient out front. So I need two numbers that multiply to 15 that subtract to give you 2. 5 and 3, and I want a negative 2, so I want a negative 5 and a positive 3. So I could set p minus 5 equal to 0, p plus 3 equal to 0. So p cannot be positive 5, p cannot be negative 3. Any other value will not give me a 0 on the denominator, so they can work. So this guy is undefined when p is 5 and when p is 3. So we really just have to be careful that we don't end up with a 0 in our denominators. Okay. Number 3, there just says simplify. I have a to the 4th b minus 2a to the 4th, all divided by 2a cubed minus a cubed b. Alright, so we're on the roll of factoring. So let's just look at the numerator. If I were to factor the numerator, what do they have in common? A to the 4th. Okay, so let's take a to the 4th out. What do I have left? B minus 2. Okay, how about the denominator? A to the 3rd, and then what am I left with? 2 minus b. Okay, those look similar, right? But are they the same? No, 2 minus b and b minus 2 are completely different, right? So then it says you can factor out a negative 1 to help you simplify. Okay, well, let's just take him out of the numerator, right? So if I were to factor out a negative 1 out of this guy right here, let's see what happens. Let me grab it. If I factor a negative 1 out of this guy, I'm just going to put him underneath so you can kind of see. I have a to the 4th, and if I pull out a negative 1, the b becomes negative, and the 2 becomes positive. Okay, that's not too horrible. Is that now the same as that? Yeah, he's now a positive 2 and a negative b. 2 minus b. Okay, so now let's think about what we get rid of. The 2 minus the b's. What about those a's? 3 of them, right? Remember our exponent rules. If they have the same base, I can subtract their exponents. Well, I've got 3 on the bottom, 4 on the top. So this guy is just a times negative 1, or negative a. questions so far? To multiply two rational expressions, you multiply the numerator and then the denominator. To divide two rational expressions, multiply by the reciprocal of the divisor. Or it has, you sometimes know it, copy dot flip. Heard that part before? Yeah, it really just means multiply by the reciprocal. There's some stuffy math people out there that don't like that copy dot flip, because there's no mathematical terminology to that, right? Yeah, I don't care. Okay, so here we go. Number 4 says simplify each expression. 8x over 21y to the third times 7y squared over 16x cubed. It said to multiply the numerators and then multiply the denominators, which we could do. But before we do that, maybe it would be easier if we simplified first, right? So at the top, we were looking for common factors between a numerator and a denominator. The same thing happens here. And if you'd like, I can write it all together. So I have 8x times 7y squared all over 21y cubed, 16x cubed. Do we have common factors between the numerator and the denominator? Yeah, let's get rid of them, right? Let's simplify this bad boy. What do you see? Okay, there's a 1x on the top, so this guy's going to become a 2. What else do you see?
Can you simplify 8 and 16?
Sure, 8 and 16. 8 divided by 8 is 1. 16 divided by 8 is 2. What else do you see? 7 and 21, right? 7 divided by 7 is 1. 21 divided by 7 is 3. The y's, right? We have 2 y's on top, 3 y's on the bottom. There's 1 left. All right. Oh, hey, what do we have on top? What's left on top? 1 times 1. Okay, what's left on the bottom? 3 times y times 2 times x squared. So 1 over 6 x squared y, or yx squared, I don't care which way. Okay, I showed lots of work there. Some of you may not need to show that amount of work, and that's okay. Try B. See if you can do B. So you should end up with 2ac cubed over 3b squared. Did you get there? Okay, let me show you. So I have a 5 on top, so 5 divided by 5 is 1. 5 divided by 15 is 3. 12 divided by 12 is 1. 12 divided by 24 is 2. Alright, so I'm going to write those down. Now, there's some common variables between these guys. So what I'm going to do is I'm going to go ahead and combine them all together. Remember, our exponent rule says if we're multiplying and they have the same base, keep the base and add them together. So I have a to the 4th, then I have a b, and I have one c here and two c's there, so I have c to the 3rd. Then in the denominator, I'm left with 1 times 3 is 3. I have a to the 3rd, b, I have one b here and two b's there, so b to the 3rd. Whoops, sorry. Okay, so now let's simplify those guys. 4 a's on top, 3 a's on the bottom, so I'm left with 1a on the top, 1b on the top, 3 b's on the bottom, subtract them, the bigger one's on the bottom, so he's going to stay there. Nobody to cancel this c cubed with. So you should end up with 2ac cubed over 3b squared. All right, what's different about C? Division, right? So instead of just multiplying straight across, we have to multiply by the reciprocal. So that's the first thing I'm going to do. 10 ps squared divided by 3c squared d, multiply by, now I'm going to flip it, 2c squared d squared, that's not a 2, that's a 6, over 5 ps. Okay, same thing. The only thing that we added a step, you just now have to flip it, right? But the same thing. Now we're going to simplify. 10 and 5 can reduce to 1 and 2. 3 and 6 can reduce to 1 and 2 as well. Two times 2 is 4. P s squared c squared d squared divided by 1 c squared d p s. And I wrote them in different order, I'm sorry. Alright, so here we go. 1 p on the bottom, 1 p on the top. They're going to go away. 2 s's on top, 1 s on the bottom. So I got 4s. C squared on the top, c squared on the bottom. That's going to go away. 2 d's on top, 1 on the bottom. I'm left with 1 on the top. 4sd or 4ds, however you want to write it. Hi, Miss Jillian. Okay, questions on any of those? Okay, let's look at D. Remember that this guy right here, k minus 3 and k plus 1, are all their factors. Okay, that's a factor in itself. I can't get rid of things if there's a plus sign or a minus sign in between them. Okay, I can only get rid of things or simplify things if there's a multiplication sign. Alright, well, I also have a division. So let's go ahead and multiply by the reciprocal. So I have k minus 3 divided by k plus 1 times 1 minus k squared over k squared minus 4k plus 3. Well, at the moment, I have no common factors, right? Also, if you notice, everything is k minus or k plus, and then this guy right here, he went a little crazy, and now he's 1 minus k squared. So just like in number 3, I'm going to factor out a negative 1 from this guy so I can flip him around. Okay, so let's do that. If I take a negative 1 out, he's negative 1 times k squared minus 1. Does that guy factor? Yeah, he's the difference of squares, right? How do difference of squares factor? Oop. Negative 1's still there. K plus 1. K minus 1. Sorry, that got a little sloppy. Okay, well, let's see if we can factor this denominator then. A minus and a plus. What are my signs? A minus and a minus. Okay, k minus, k minus. You need two numbers that multiply to 3. Signs are the same, so it adds to 4.
3 and 1.
3 and 1. Okay, now let's find common factors. What do you see?
K minus 3 and K minus 3.
There's a k minus 3 on the bottom and a k minus 3 on the top.
K plus 1 and plus 1.
K plus 1 on the bottom, k plus 1 on the top.
And K minus 1.
K minus 1 and a k minus 1. One on the top and one on the bottom. Okay, it doesn't have to be diagonal, it just has to be somewhere on the top and somewhere on the bottom. What am I left with? Negative 1. Who would have thought? All of that became just a negative 1. Okay, so look there at number 5. Turn the page and we'll go to 5. So it says simplified 2d plus 6 all over d squared plus d minus 2 divided by d plus 3 divided by d squared plus 3d plus 2. Ooh, there's a lot of d's in there. Okay, so first of all, you're noticing a trend, right? We're doing lots of factoring. So let's start with this guy. What do they have in common? A 2. Let's take it out. What am I left with? D plus 3, right? Would it help if I put the sign chart on the board? Do some of you need the sign chart? Okay. Got it. Nope, we're good. Plus and a minus. What are my signs? Plus and a minus. Woo. Multiplies to 2. Subtracts to give you 1. I want a positive 1, so positive 2, negative 1. Okay, also notice that this guy's division. Would it be okay if I flipped and factored at the same time? Okay. D plus 3 he's already factored out, so I'm just going to leave that guy there. But let's factor this guy. Plus and a plus is a plus and a plus. Multiplies to 2. Signs are the same, so it adds to 3. 2 and 1. Okay, look for common factors. What do you see? A D plus 3, perfect. What else? D plus 2. What about these two guys? Are those the same? No, they have to be exactly the same. One's a plus and one's a minus. You can leave your answers in the completely factored form. So this guy is 2 times D plus 1 all over D minus 1. You don't have to distribute that 2 back out. You can leave your answer in the factored form. Does that look nasty? So he's like, don't make us do that last one. I'm going to make it so much easier. You just did one. Remember that fraction bar just means divide, right? Think about all the symbols that we have for division. We've got this guy right here, but also know that this guy right here, that fraction bar, also means divide as well. Okay, so a complex fraction is a rational expression whose numerator and or denominator are also rational expressions. So, a rational expression whose numerator and or denominator contains a rational expression. To solve a complex fraction, rewrite it as a division problem and simplify. Okay, so number 6 looks a little gnarly, right? Think about it as the apartment complex of fractions. Right? The top apartment has a fraction and the bottom apartment has a fraction too. But remember that this guy right here just means divide as well. So let's write it with the other symbol. Okay, so x squared divided by 9x squared minus 4y squared divided by x cubed over 2y minus 3x. Well, doesn't that look just like that guy? Yeah. So he's not as scary, right? Just slightly scary, not 100% scary. Okay, well, we can't divide, so we have to multiply by the reciprocal, right? Okay. So I got x squared over 9x squared minus 4y squared times 2y minus 3x all over x cubed. Now what? Factor, right? He's the difference of squares. 9x squared minus 4y squared. Anybody want to take a stab at factoring that guy?
No.
Kind of like that guy, right? Take the square root of both. Okay, well, let's try. 3x minus 2y. 3x plus 2y. Okay, so they're close. What do I have to do to that guy? Pull that negative 1 out, right? You're welcome. So this guy is now 3x minus 2y. over x to the third. Okay, common factors. What do you see? Okay, there's a 3x minus 2y. We have an x squared and an x cubed, right? So that guy's going to go to 1. So in the top, I'm left with negative 1 divided by 3x plus 2y times x. And if you want to write it the other way, that's okay too. Bless you. Okay, questions? Jillian. So they look similar, right? So 2y minus 3x looks almost like that guy, but not quite. They're different because their location is changed. So what I'm going to do is if I divide this guy by negative 1, he becomes the negative 2. And if I divide negative 3x by negative 1, he becomes positive. So they flip their places so that they become the same factor. I'll show you the front side of the